Welcome to Mastering Solutions. If we make a list of everything we're given in the question, we're told that the object distance, which in this case is the moon, right? The object distance is 3.8 times 10 to the 8 meters away from the Earth. So that is the object distance for this question. We're told that the image height, or the diameter in this case, it's the same thing, is going to be 3.5 times 10 to the 6 meters. We're also told the focal length of this converging mirror, and that is 1.2 meters. So 1.2 meters is our focal length, and all of them are in SI units already, so that's nice. We don't have to convert anything. Now we're trying to figure out what's the diameter of the moon's image. So that, just like we were talking about here, we're trying to find the image height. That's what we're trying to solve for the question. We can use the equation that we've used in a lot of previous questions. The image height is equal to the object height times the ratio of the image distance over the object distance. You'll know that in some of the previous questions where we've done this, sometimes you'll see a negative value here. You could put that in there, but what it would be telling us is if the image is inverted or upright. We don't particularly care about that in this question. We're just trying to figure out the diameter of the image, and if it's inverted or not, it's going to be irrelevant because it's a circle. And so we have the object height, we have the object distance, but we don't know what the image distance is, right? So we have to use the thin lens equation to solve for that. We know that 1 over f is equal to 1 over s prime plus 1 over s. We're trying to solve for this. So if we minus over 1 over s, we have 1 over s prime is equal to 1 over the focal length minus 1 over the object distance. So 1 over s prime is equal to 1 over the focal length, which we said was 1.2 meters. And since we have a converging mirror, that is going to be a positive value. Now we'll subtract from that 1 over the object distance, which we said was 3.8 times 10 to the 8 meters. And again, since this is on the upstream side of our mirror, then this will also be a positive value. So we have 1 divided by 1.2 minus 1 divided by 3.8 times 10 to the 8. And that gives us 0.833 diopters. But we want this in meters, right? And so we need to take the reciprocal of that, and that will change this to meters. So we have an image distance of 1.2 meters. So now we can plug that into our equation over here to finally solve for the diameter of our image. So h prime will be equal to h, which we said was 3.5 times 10 to the 6 meters. Now we're going to multiply that by the ratio of the image distance, which we said was 1.2 meters, divided by the object distance, which is 3.8 times 10 to the 8. So we have 3.5 times 10 to the 6 multiplied by 1.2 divided by 3.8 times 10 to the 8. So that gives us in meters 0.011. So if we move it 1, 2, and so that will give us 1.1 centimeters is the diameter, or in other words, the height of our image of the moon.